Hey brother, what's this weird symbol on this power button?
That comes from binary.
What's binary?
Binary is a number system made of zeros and ones, where zero means off and one means on. So if you combine these two, you get that symbol on the power button.
That's cool. Thanks. Bye. I tell my mom.
Now let's talk about binary. Binary was invented by a French man named Gottfried Wilhelm Leibniz in 1679, and he published it in 1703. He wanted to find a system that converts logic verbal statements into pure mathematical statement. Did you know that the first modern language that uses binary is Braille, that was made in 1824? As you can see, Braille uses 6 dots where some are raised and some are not, just like 0 and 1. Also, binary is the reason why we live in the digital world today. Binary is used in all kinds of our technology, such as cell phone communications, digital TV, communications, computers, and more. This is because binary is useful in converting our analog world into the digital world. Now, let me give you another example. You see, when you type on a keyboard, the keyboard doesn't send your computer alphabets. Instead, it sends binary numbers. You see here, my name in binary is not ETHAN, but rather 0100011010 and so on. Now, let's go see how you can convert binary and decimal, or base 10, and also let's do some addition and subtraction with binary numbers. So now, let's see how to convert from decimal to binary and how to add and subtract binary numbers. You can see that I wrote this small subscript here. This tells the number base that the number is. So 10 is decimal, or base 10. We usually don't write this because we don't use multiple bases and it would be very inconvenient to write it every time we write a number. But in this case, it's absolutely necessary because without these numbers, it would be very easy to get confused. So now let's convert, and now you can see that I put exponents here. This shows how many times a number increases as it goes from one digit to another. As you already know, one digit increases by the powers of 10 as you go on. So 1's place, 10's place, and 100's place. In binary though, because it's base 2, we increase by powers of 2 instead of 10. So it goes from 1, 2, 4, 8, and so on. So now let's convert our base 10 number, which is 121, into base 2. So first off, let's just figure out if 121 is odd. Well, the answer is yes. So we definitely have a 1 right here. 1. So because we accounted for that 1, we're going to subtract it and we have 120. Now, let's see the power of 2 the largest power of 2 that can go into 120. 2 to the 7th power is 128, which is too big. But 2 to the 6th is 64. So we'll definitely have a 1 here. So 120 minus 64, and we get 56. Now let's see if 56 is large enough to hold another 64. Well, no. So let's see if it can hold a 32. Well, 56 is obviously greater than 32, so there will be a 1 here. Okay, now we just subtract 32 from 56, and we get 24. Now let's see if 24 is large enough to hold 16. Yes, so 116 here. 24 minus 16 equals 8, and looking for us, 8 is an exact power of 2. So we'll have an 8 here, and a 0 in the rest of our digits. It's as simple as that. Now let's double check if we got the right answer. 1 plus 8 plus 16 plus 32 plus 64 equals, these two make 10, also these two make 10. 10 plus 10 plus 1 is 21. 1 plus 3 plus 6 is 100. The 2 comes down. And now we are sure that 1111001 in binary is the same thing as 121 in decimal. Now, let's see how to add and subtract with binary numbers. So first, let's do addition. Addition is actually pretty simple. First off, you see we have a 0 and a 1 here, right? If you have the 0 ones and the 1 1, you obviously get 1 1. So 1. And now here's where another part of your base 10 math comes in. So you see when you add two numbers and it goes more than 10, you move 1 to the other next digit and you put the remaining digit down. And this is what it happens. So we have 1 and another 1 in the 2's place, which means 2 plus 2, which equals 4. However, this is the 4's place, and we have no other number. So let's put 0 and put a 1 on top of here. Let me do it like this. So, with the 1 on top, let's proceed. So now we also have two 1's in our 4's place. 1, 4 plus 1, 4 equals 2 4's, which is 8. So we're going to have to put a 0 here and move an 8 to the 8's place. Now, there are no more 1's here. So we can just bring the 1 down. And as you guys should know by now, we have another two 1's in our 16's place. 16 plus 16 is 32. So we drop a 0 here and add a 1 here. And because there's pretty much zeros here, we can just bring the 1 down. So 10110 plus 10011 equals 101001. Now let's try subtraction in binary. So here I have a subtraction problem with binary. It's 1101001 minus 1010011. And obviously, 1 minus a 1 equals 0. So we're going to put a 0 here. Now, we have 1 below a 0. So we're going to have to borrow from the next digit. Well, it just happens that the 4th digit is empty. So let's borrow from the 8's place. This 1 will no longer become 1. Instead, it'll be 0. Right? 1 minus 1 equals 0. So it's going to donate 2 4's to this side. But because this guy's got to donate another 2 here, it's going to become 1. And this guy will become 2. And 2 minus 1 is simple math. 1. Okay, now let's proceed. 1 right here minus a 0 is 1. 0 minus 0 is 0. And now we're at this problem again. 0 minus 1. So now you know how to address it. So let's borrow it from the, where was it? 32's place. So this will become 0 32's, and this will become 2 32, 2 16's. 2 minus 1 equals 1. Now 0 minus 0 equals 0. 1 minus 1 equals 0. You get rid of these zeros because it's absolutely unnecessary to put zeros in front of your number. And now we have our answer. 10110. And like addition, you can also alternatively convert both of these to base 10, subtract them, and reconvert them to base 2, and that will require quite a bit of steps. Thanks for watching. Bye!